Hello everyone, and welcome to another tutorial video of the Plastics Engineering Department at UMass Lowell. Today I want to show you how to plot your viscosity data measured from a capillary rheometer. We are starting with a new Excel sheet where we're going to import our lab data and then plot them accordingly. So we go to our data measured by the capillary rheometer. In this case, this was an LDPE measured at 190 degrees C. We're going to select our data which we need, which in our case is the shear rate as well as the viscosity. So we are selecting these data by right-clicking, copying them in our blank Excel sheet, and then pasting them here and label them accordingly with the measured temperature, which was 190 degrees C. To plot these data, I will show you two ways. The first one is going to the insert page, then selecting, in our case, a scatter plot. Select the data, add new data set. Our series name is going to be the temperature we measured these data at. Our X value is going to be the shear rate, and our Y value is going to be the viscosity. And here we have the data in our graph. Another way to plot your data is to pre-select the data you want to plot. Go to the insert page and then go to the scatter plot, which will leave you with the same result. Excel automatically assumes your data on the left column as your x-axis values and your right data set as your y-axis values. So to scale our graphs, which are necessary for viscosity data, we are going to double-clicking on the axis scale, which is opening the formatting tool of this axis. In this case, we want to plot our data in a logarithmic scale. We select this for our first axis, and then by selecting the y-axis, the window will change, and we can select here also the logarithmic scale value. And then if we name our graph to identify it, and then in the last step, we are going to click on a graph, go on the plus sign, and then add our axis title to identify what data we're using, which is the shear rate and the values of 1 per second on the x-axis, and the viscosity in Pascal per second on the y-axis. Now you have your finished graphs for the lab report.